All right, this is Unit 1, Lesson 2, Absolute Value Equations and Inequalities. Today we'll be reviewing how to solve compound inequalities and once again reviewing our interval notation. By the end of today's lessons, you should be able to solve compound inequalities, graph compound inequalities on a number line, and write an inequality using interval notation. All right, so solving compound inequalities. Go ahead and really quickly, let's review how to solve an inequality itself and graph our answer on a number line. So remember, we treat an inequality just like an equation when we're solving. Isolate the variables on one side, move your constants to another, and divide. So go ahead and subtract 1.5x. Get my pen. Now at this point in the game, I should expect that you do not need to write this down. In fact, we should be able to quickly move through writing down the subtracting by 1.5x on either side. Okay? Just doing it right now to show you where we're at. So we've got x is less than or equal to 13. Okay, so just a reminder when we're putting it on a number line, here's 13, put a number on each side. Less than or equal to, shade to the left. Okay, closed circle for equal to's, open circle for not included. Over here, we're going to add 5x. Doesn't matter which way you move things. Just be careful at the end if your variable's on the right side, which ours will end up being. You also could have added 9x, subtracted 9x from both sides. So I get 7 is less than 14x. Divide by 14. Now this is 7 divided by 14, not 14 divided by 7. So I've got 1/2 is greater than x. So when I'm graphing that on a number line, x is less than or equal to 1/2. So I've got 0, 1, 1/2 is in the middle. Open circle, shade to the left. Okay, because x is less than 1/2. Or 1/2 is greater than x. All right, so just review real quick. When graphing less than or greater than on a number line, you can use an open. Okay. When graphing less than or equal to or greater than or equal to, we can use a closed. I'm talking about a conjunction. In the first lesson, we learned about unions, okay, using the word or. A conjunction is the word and. It has to satisfy both inequalities in order to be a solution. Okay, versus an or, we kind of shaded in either direction. Either x was smaller than 0 or it was greater than 10. Okay, here it has to be an and. So we're looking at 10 is less than 40 and it is greater than 32. So really we're looking for values between those two. So in order to think about our solution, let's go ahead one at a time and take a look at them. All right, so we're saying t, so let's start by t is less than 40. Open circle, shading this way. My second graph is t is greater than 32. Open circle, shading this way. So since it's an and, it's a conjunction, I want to find which section of the graph satisfies both. So when I'm where they overlap. So I'm going from 32 up to 40. Okay, and of course it's not inclusive because it's just less than or greater than. All right, so for a conjunction, it's where they overlap. Ooh. All right, so this is important. A solution to a conjunction must solve both inequalities. The solution to a conjunction is the intersection of the solutions, where they intersect or overlap or cross each other. Important to know. All right, a disjunction. Okay, so if we're given that g is less than 1 or it's greater than 3. So this is that or statement that we looked at before, the union. Okay, disjunction. In order for the statement to be true, only one or the other inequality must be satisfied. All right, so we're just graphing them. So g is less than 1, 1 shade to the left. G is greater than 3, shade to the right. So when I'm looking at both, it's either going to be g is less than 1 or g is greater than 3. Okay, I'm shading everything possible. Okay, they don't need to overlap because it's an or, it's a disjunction. They don't have to both be true. When I have an and statement, a conjunction, they both have to be true, and I'm looking for their intersection. Here I'm looking for their union, which is a combination of the two graphs. Okay, a solution to a disjunction need only solve one of the inequalities. The solution is a union. Union is OR. All right, so we're going to go ahead and solve these and graph. So our little starred statement on the right says, don't forget to reverse the inequality when you multiply or divide both sides by the same negative number. So just be careful there. All right, so solving our inequality, subtract by 3. So I've got 2x is greater than or equal to 4. Divide both sides by 2. X is greater than or equal to 2. Subtract 1 on both sides. So I have negative 3x is greater than or equal to negative 12. I'm dividing by negative 3, so I'm flipping my inequality. Now this is an and statement, so I'm looking for where they're overlapping each other. I'm looking for the intersection. So let's go ahead and graph one at a time. 2, 4, 2. So if I'm graphing x is greater than or equal to 2, 2, shade to the right. X is less than or equal to 4, 4, shade to the left. Now I want the conjunction. So I'm going from 2 to 4. Here's where they overlap. That is my solution. Okay, and if you want, you could write that as one inequality. Okay, you can write conjunctions as one inequality because really that's what's represented. X is in between 2 and 4 inclusive. All right, so now I have an OR. So an OR is telling me there may not be overlapping. Okay, there may not be overlapping. So I'm going to go ahead and solve this. I'm going to add 4x to both sides. So I've got 2x plus 5 is less than 3. Subtract 5 on both sides. I've got 2x is less than 2. Sorry, negative 2. Divide, x is less than negative 1. Over here, I'm going to add 2, so 3x is greater than or equal to 6. Divided by 3, x is greater than or equal to 2. All right, so when I go ahead and graph, I've got negative 1 shaded to the left, 2, closed circle, shaded to the right. Since it's an OR, it's just going to be both of those together. All right, our next example is an AND, so I'm looking for an overlapping shading. Okay, solving, oh, it's the same problems. Okay, so I see I have that. So I've got x is less than or equal to negative 1, and I'm looking for where x is greater than or equal to 2. All right, so I can go ahead to my number line again. Let's take a look at what happens. Negative 1 to the left, 2 to the right. Since this is an and, I'm looking for where they overlap. But what do we notice? They don't overlap. There is no intersection between these two. So what is our ultimate solution going to be? There isn't one. This is a no solution. Okay, I cannot have one number that satisfies both inequalities. No solution. You can also draw a 0 with a line through it to indicate no solution. Okay, there is no intersection. So see how that word in between really makes a difference? I need to know whether I'm looking for a union, an or, either this or that, or an intersection, an and, looking for where they both satisfy. Okay? All right, let's take a look at our next example. This box always in the way. All right, so I'm going to subtract 7. So I got x is greater than or equal to negative 5. Divide by 2, and I've got x is greater than or equal to 2. So I'm looking for an and, where they overlap. So my first problem, negative 5, shade to the right. My second problem, 2, shade to the right. So I want to know from where they both overlap. Okay, now notice they're both getting bigger and bigger. So where does that start at? Right here at the negative 2. This is where they have in common. So my answer is going to be that x is greater than or equal to 2. Shaded to the right. All right, down here I've got my or, so I'm saying, hey, either or. So it's either going to be negative 5 to the right or 2 to the right. So in this case, since it's either or, I'm really just going to be looking from negative 5 and up. I don't need to do anything with the 2 because it's already included in my solution. Okay, so if there is overlapping over the majority of it, just look and decide, okay, do I get to include everything, or do I have to start at maybe my bigger number if I'm going to the right or smaller number to the left? All right, interval notation. This is just a quick review of what we already learned so we can continue on. All right, so we're going to write the following inequalities in interval notation. Just a reminder, remember, equal signs included, it's a bracket, so I'm going from -5 to 10. Brackets from 4 to 8.5, which gets a parenthesis. Greater than -2, so I'm going from -2 up to infinity. Parentheses for both. Less than 7, -infinity to 7, parentheses. 1 to 5 gets parentheses. Go ahead and write the inequalities so I'm going the other direction. -6 is less than x, which is less than 4. From -infinity, so I'm saying x is less than 1.5. -2 is included, 2 is not. -3 is included, and so is 3. And I'm going 8 and higher. All right, so just a note, most or, person in or, in a boat, inequalities you encounter will have graphs where the line is shaded to either side, like oars on a boat. Okay, so an or, most often or not, unless you have that overlapping one that we looked at a minute ago, is going to look like oars. They're going in either direction. Most and inequalities you encounter will have graphs where the line is shaded between the points. Think then is between As a quick summary, solve each portion of an or compound inequality separately. And inequalities can be solved separately when written using the word and, or together when written without the and. All right, so that's what it's saying down here. X is greater than 2 and x is less than or equal to 4 is the same as writing as one big inequality. Answers must be written as conjunctions or include the word or and to be correct. Okay, so you need to make sure you know what you're going with there. An interval notation is an alternative form for writing the solution to an inequality.